we are going to discuss about next topic of next topic of physics. Before that, we can just check what we discussed, what we studied in the previous class. In the previous class, we studied about Ohm's law. That means Ohm's law, from that we got potential difference directly proportional to current flowing through a conductor. That means V proportional to I at a constant temperature. And from this we got the relation V by I equal to R. This R is called resistance. This R is called what is resistance of the conductor. Then the unit of this ohm is ohm, and the symbol used for this is this one. Then we discussed about different types of conductors. That means good conductor, then poor conductor, resistors, also insulators. That means good conductors which allows electric current flow very easily through it. Poor conductor, the current flow through it is opposed by the atoms present in it. So the conductivity of it is less than compared to good conductors. That means less than that of the good conductors. Then resistor. Here also, when electron flows through it, the atoms oppose or the atoms attract that electrons, hence the motion of it becomes as not so good as in the conductors. Then insulator, its conductivity or its electrical conduction is very small. Now also we discussed about another one term, that means graph of this Ohm's law. That means what we got? That means a graph like this I, V, and the graph is a straight line. What type of graph we got? We got a straight line graph. Okay, these are the things we discussed in our previous class. Now we are going to discuss about the factors on which resistance of a conductor depends. Which are the factors that resistance of a conductor depends? For that, we can do on activity. Factors that affects resistance of a conductor. Factors that depends on resistance of a conductor. For that, we are going to do on activity. For that, we require a nicron. wire of length L. So it is 25 centimeter. And second, another nichrome wire of length 2L. Then it is near 50 centimeter. Then another one, a thick nichrome wire, same length L. Then a copper wire, length L and thickness same. See what we are going to discuss. We want to find the factors that depends on resistance of a conductor. For that, we require these materials. A nichrome wire of length L, say we are going to take its length as 25 centimeter. Then another nichrome wire of length 2L, that means double of this one, 12 means here it is 50 centimeter length. Then a copper wire of length L, that means this is a nichrome wire. This nichrome wire of length here we took as 25 centimeter. Then another nichrome wire that is connected here, that you can see, and its length is 50 centimeter. And then 12, that is length L and 12, but thickness of these two are same. Here we took another nichrome wire of thickness more than that, double of this thickness we can take, and length same. That is, we took a nichrome wire which is more thick but length same as this one. Then a copper wire, its length also some that means like 50 centimeter and thickness as that of this one. Now the circuit which we made with like here we are going to connect this, then here on battery, then on switch, then ammeter, in this way is the circuit. See, here we can connect the means from the negative and positive to positive. At first step, the means circuit which we require for the activity is this one. Here we are going to connect a nichrome wire and copper wire, more thick nichrome wire, etc. See, the circuit is shown here. You can see the circuit, battery eliminator, ammeter, and also switch. And see here at first step. Here you can see the nichrome wire is connected in this. In this there is a gap. So nichrome wire is in the circuit. Then this is the switch we using. And from you can see, that means this red one is the positive of the ammeter, and that positive is connected to the positive of the battery, and this negative is connected to negative. And now see here in the circuit we included a nichrome wire. You can see a nichrome wire. That here is a gap, so current only can flow through this one, not through here. But when we put this switch, when we open this one, here switch is open, that means circuit is open. And we put here, that means the circuit is completed. Okay. Now see, after opening this switch, I am going to switch on the current. Here you can see current, and see in the ammeter there is no reading. You can see there is no reading in the ammeter. And now I am including this. That means going to close the circuit. Now the circuit is closed. You can see current in this. Observe the current in this. That is 0.5 ampere current you can see in this. You can see 0.5 current, that means the needle is in 0.5. Can you see? Yes, observe it. Now current you observed here. Now what I am going to open the switch. This wire is getting heated up because it is a nichrome is a resistance, that means high resistance wire, hence it is getting heated up. Now I am going to replace this nichrome wire with a nichrome wire of its half length. See, this nichrome wire is with a half length only. Now this nichrome wire is in the circuit. Now we are going to include this nichrome wire in the circuit. See, now nichrome wire is in the circuit, and now I am going to put this switch. Switch is going to on. Now switch on. See the current in the ammeter. Can you see the current in the ammeter? You can see current now is in 1 ampere. See, near this needle is in 1 ampere. Okay. Now current is 1 ampere. Now after opening this switch, at first when the nichrome wire of length 12, that is double length, current is only 0.5 ampere. Now nichrome wire of length L only, current is 1 ampere. You can see the current. Once again you see, here is no readings in the ammeter, but when I put this, you can see, once again, when I am going to switch on, you can see the deflection. You can see the deflection. That means current now 1 ampere. Now I am going to replace this nichrome wire. That means length of these two are nearly equal. See. Now this nichrome wire I am going to replace with a copper wire here. Now see which wire is in the circuit. Now copper wire is in the circuit. Now I am going to switch on again. See. When I switch on, see current in the ammeter. That means you can see current in the ammeter. How much is it? It is nearly 4.4 ampere. If I am removing this switch, see, current is 0. When I am on, see, current is 4.4 ampere. Now, from this, you can understand the things are, when we use a copper wire, current is 4.4 ampere. In a similar way, if we use a thick nichrome wire, then also you can see current more than this 1 ampere. From these activities, what are the things we can obtain? See, when the current in the circuit increase, at first when the wire is, that means a nicron, wire, its length is L. How much was the current through it? 1 ampere. When the length of the nicron wire be doubled, that means 12. At first, that one I showed, the current was 0.5 ampere. When nicron wire replaced with copper wire of same length, that means here we use copper wire, then we got it is 4.4 ampere. 4.4 ampere we got from the ammeter. Now, in the same way, if we use a thick nicron wire, then also the current is more than this. So, current flowing through depends on what is length, then thickness and material. Current flow, here we given same potential. Potential is not altered. Same potential is given. Hence, current flowing through the conductor is directly proportional to what is its resistance here. That means when the resistance depends on, from this current we can define, that means we can observe in different values why the current differ here. Potential is same, then potential is not changing. At the same potential, current depends on resistance. Current depends on resistance. So resistance depends on length of the conductor. That means when the length of the conductor increases, here current see decrease. That means if the conductor of length double, current we can observe becomes half. That means resistance depends on length of the conductor. Resistance depends on length of the conductor. Second, resistance, that means when the thickness of the wire increases. When the thickness of the wire increases, what happens? Resistance also we can observe decreasing. Resistance is decreasing. When thickness is increasing, resistance is decreasing. So resistance is inversely proportional to material. Inversely proportional to area cross section of the material. Thickness means area cross section. Thickness means what is area cross section. So resistance is directly proportional to length. Otherwise, resistance depends on length of the conductor, which means when the length increases, resistance also increases. So current decreases. When the thickness increases, resistance decreases. When the thickness increases, resistance decreases. And also it depends on material. It also depends on material of the conductor. So, resistance of a conductor depends on mainly three factors, which are on length. As the length increases, resistance also increases. Second one, when area cross section or thickness increases, resistance decreases. So, resistance depends on area cross section. Third one, it depends on material, because here copper and nickel we use current differ because of resistance difference, because of the difference of resistance. Hence, it depends on material. And also, these are all we can say if the temperature is constant. If the temperature changes, then the resistance also can vary for material conductor, such as if for the metal, as the temperature increases, resistance also increases. Temperature increases, resistance also increases. That is the fourth factor. So, which are the factors that depends on resistance of a conductor? On length of the conductor, it is directly proportional. It means If length increase, resistance increase. Second one, thickness or area cross section. It means if thickness increase or area cross section increase, resistance decrease. Thickness increase, resistance decrease. And third one is material of the conductor. Material of the conductor. Example here we use nichrome wire. That is one material. Another one is used copper wire. That one another material. But the current we cannot see as same. That means resistance differ there. From this we can conclude resistance depends on length of the conductor, area cross section, and material. If these are take place at the same temperature, if the temperature changes, then it also depends. Temperature, that means resistance also depends on temperature. As the temperature increase for metallic conductor, resistance increase. Then if the temperature decreases, resistance of the metallic conductor decreases. For metals or non-metals, as the temperature increases, resistance decreasing. Here you want to remember which are the factors that depends on resistance. Which are them? On length. 2. Area of cross section. And third one, material of the conductor. Material of the conductor. That means these are the three factors. At a constant temperature, resistance of a conductor depends. Now, how these depends? See here. That means the resistance is directly proportional to length. Which means as length increase, resistance also increase. Another, resistance is inversely proportional to area of cross section. Resistance is inversely proportional to area of cross section, which means if area cross section increases or thickness increases, resistance decreases. By comparing these two, we get R proportional to L by A. R proportional to L by A, or R equal to, we can remove this proportionality sign by giving a constant, and it is called rho, which is the letter rho. Rho is the proportionality constant. Here rho is the proportionality constant, and it is called resistivity. Resistivity of the material. That means resistivity of the material. That means resistivity is the resistance of a conductor of unit length and area cross section. See here, suppose we are taking a conductor of length 1 meter. Then area cross section is 1 meter square. Then here by putting, we get what is R equal to rho into L1 by A1. 1 by 1, 1. That is R is equal to rho. So resistivity is actually what? Resistance. Resistivity is actually resistance of a material of length 1 meter means unit, and area cross section 1 meter square means unit area cross section. So resistivity is the resistance. Actually resistivity is the resistance itself for a conductor of unit length and unit area cross section. Okay. See here we obtain the relation but R equal to rho L by A. From this rho is equal to, I will get this A and R A by N. See, rho is equal to RA by L. We can write the unit of this one. Resistance unit. That means the resistance unit is which? Ohm. And the area unit is meter square. and unit of length meter. Now 1 meter we can cancel. Then what will remain? Ohm meter. Then unit of what is resistivity is ohm meter. Unit of resistivity is what is ohm meter. Which is the unit of resistivity? Ohm meter. Resistivity is a specific property of a material. That means for a material, its resistivity is same at a particular temperature. If the temperature changes, resistivity also can change. And resistivity, that means the resistivity of this nichrome and copper are not the same. Even if you take a same length, same area cross section, even though their resistance may be same, then its resistivity may not be same. That means resistivity is the specific property of a material. Resistivity is the specific property of a material. Now, for see, can you remember R proportional to L, R proportional to 1 by A, comparing these two, R proportional to L by A, this proportionality we replaced with a constant rho, and rho is called what is resistivity. What is the term? Resistivity. From this rho is equal to, from this relation rho equal to R A by L. We are going to write the unit of rho, that means resistivity. Unit of resistance O. Unit of area meter square. Unit of length meter. Up and down 1 meter we can cancel. Then what we will get? Ohm meter. The unit of resistivity. Now, for metallic conductor, resistivity depends. That means when we comparing with the metals and alloys, resistivity of, that means metals is smaller than that of resistivity of, what is resistivity of this conduct, that means alloys. That means metals resistivity vary from 10 raised to minus 8 to 10 raised to minus 6. 10 raised to minus 8 to 10 raised to minus 6. That is resistivity of the metals varies from up to, what is from 10 raised to minus 8 to 10 raised to minus. For insulator, resistivity is very high. Resistivity of some of the materials given here, let us look. That means here, see, silver, its resistivity. Silver, its resistivity is given as 1.60 into 10 raised to minus 8 ohm meter. For copper, it is 1.62 into 10 raised to minus 8 ohm meter. Then for aluminium, it is 2.63 into 10 raised to minus 8. Then for tungsten it is 5.20 into 10 raised to minus 8. Then for nickel, in this way it is going on. And for manganese it is that means manganese, for manganese it is 1.84 into 10 raised to minus 6. That is why just before we discussed that means resistivity is varying from 10 raised to minus 8 to 10 raised to minus 6. Among this you see resistivity for the metals here, the least resistivity is for silver. That is, silver is with the least resistivity. That means it is the good conductor among these all. That is, which is the finest or greater conductivity material means it is silver. Okay, silver is the metal with the conductivity highest. But for making electrical wire and other, we use copper and aluminum. What is the conductivity of copper and aluminum? That is, these two are the conductivity, that is resistivity. Resistivity of copper and aluminum. See, 1.62 into 10 raised to minus 8 for copper, and for aluminum it is 2.63 into 10 raised to minus 8. Among these two are we used to for making, these two are we used to for making electrical lines or transmission lines. That's which wire is used to copper and aluminum wires. But what about the conductivity, that is resistivity of this tungsten? See, tungsten is, its resistivity of tungsten is 5.20 into 10 raised to minus 8. Compared to this one, its resistivity is more. But this tungsten is used for making filaments. Tungsten is used for making filaments. Once again, see, conductivity of metals varies from 10 raised to minus 8 to 10 raised to minus 6. Some of the metals conductivity is given silver with the lowest resistivity. With the lowest resistivity, conductivity means reciprocal of resistivity. Here, conductivity is actually what is the reciprocal of resistivity. Now, silver with the lowest resistivity and copper resistivity is a little bit more than that of silver, and then copper again it increases a little bit more. Then for tungsten, for manganese, how much it is? 1.84 into 10 raised to minus 6. 1.84 into 10 raised to minus 6 is for manganese. These are the resistivity. These are the resistivity of the resistivity of certain metals. Now let us observe resistivity of some alloys. Constant. That means its resistivity is 49 into 10 raised to minus 6. Resistivity of constant. And magnet, it's this one is about constant. Resistivity of what is a constant. Then resistivity of magnetic. Magnetic is how much? 44 into 10 raised to minus 6. Now from this we can understand that is and for nickel. It is 100 into 10 raised to minus 6. 100 into 10 raised to minus 6. For metals, resistivity is smaller compared to these alloys. For constant, it is 49 into 10 raised to minus 6 ohm meter. But for magnet, it is 44 into 10 raised to minus 6. For nickel, it is 100 into 10 raised to minus 6. See, this one's resistivity is compared to metals more. Hence, this does not oxidize at high temperature. this is not oxidizing at a high temperature as compared to metals. Hence, these alloys are used for making. Hence, these alloys are used for making heating coils in electric iron and also toaster, etc. Why these alloys using? This on resistivity is compared to metals is higher, and this does not oxidize at a high temperature as when we comparing with the metals. So we using these alloys in heating coils such as where in electric iron and also in toaster, etc. Now insulator, see here, what is the resistivity of the insulator? Glass. Its resistivity is given 10 raised to 10 to 10 raised to 14. That means resistivity of glass, it is vary from 10 raised to 10 to 10 raised to 14. And hard rubber, it is 10 raised to 30 to 10 raised to 16. That means for hard rubber, resistivity is 10 raised to 13 to 10 raised to 16, and for ebonite it is 10 raised to 15 to 17, 10 raised to 15 to 10 raised to 17 for ebonite, and for paper it is 10 raised to 12. That means resistivity of the insulators is very high. Resistivity of the insulator is very high. Some of them are glass, then about what is hard rubber, then ebonite, paper, its resistivity is 10 raised to 10 means here 1 with the 10 0, that means very high. And here for paper it is 10 raised to 12, that means with the 1, how many zeros we want to put? 12 zeros we want to put 3, 6, 9, 12. This much resistivity is for paper. So paper also acts as what is a insulator. That means the resistivity of what is metals are very low. Resistivity of the alloys are more than that of metals, and a special property of it is that it does not get oxidized at a high temperature. So we use there that in heating coils. Then for insulator, its resistivity is very high. Its resistivity is very high compared to this. See, resistivity of glass 10 raised to 10 to 10 raised to 14, and for hard rubber it is 10 raised to 13 to 16, and for ebonite it is 15 to 17, and then for paper it is 10 raised to 12. See the resistivity of different metals are different. Now from our Ohm's law, we are going to solve one more problems which is given in our text. The potential difference between the terminals of an electric heater is 60 volt. That means potential difference is given as 60 volt. When it draws a current of 4 ampere, it draws a current of 4 ampere. Current I is equal to 4 ampere. From the source, what current will the heater draw if the potential difference is increased to 120 volt? If the potential difference is increased to 120 volt, how much current it will increase? See, at first the potential difference is 60 volt and the current through it is 4 ampere. From Ohm's law, we know resistance R is equal to V by I. Here R is equal to V. potential difference at first is given 60 volt and the current it drawn at that time, the current flowing at that time is 4 ampere. So 60 by 4, that is equal to 15 ohm. See, this is the resistance of that device. This is the resistance of that device. See, if the potential difference now we are going to apply 120 volt. What we want to find? We want to find the current. Now one question may arise, that is, for what we find out resistance here? Why we find here resistance here, not asking to find the resistance, but we find at first resistance. Why? Because we know for an appliance its resistance is constant. For an appliance, that means that is already constructed or made. So its resistance is constant. That means if you apply 60 volt, 120 volt or 75 volt or 110 volt, its resistance does not change. Its resistance does not change. So we find at first resistance of that appliance. See, we got it as 15 ohm. Now what we want to find out? Now we want to find out current through the appliance when the potential difference is on 20 volt. Now we can find it. Current I is equal to the potential now applied is on 20. And the resistance of the appliance is, that means I is equal to V by R. I is equal to, this relation we know, I is equal to V by R. So I is equal to 120 by R 50. That is equal to, when we divide 120 with 15, how much it will be? It will be 8 ampere. It will be 8 ampere. Okay. Now, today we discussed about what are the terms on what is actually Ohm's law that we discussed earlier in class, and then it's a graph, factors affecting resistance, good conductors, bad conductors. Which are the factors that affect the resistance? On, let me say, length. Second one, that means resistance depends on length. Second one, cross-sectional area, or otherwise area cross-sectional area. And third one, what is that means material. These are the factors if the temperature is the same. That means if the temperature is not varying. Then we discussed about resistivity. How we got from the relation R is equal to rho L by A. Here this rho is the constant of proportionality, and from this we got rho is equal to R A by L. We wrote its unit as how, that means R ohm, area meter square, length meter, by cancel 1 on meter we got how much here? Ohm meter. This is the unit, and it is the speciality for a metallic conductor, and that may not the same for other one. That means for each material this one is different. Then resistivity and its unit. Then which one is the with the least resistivity? That means metals with the least least resistivity. It varies from 10 raised to minus 8 to 10 raised to minus 6. Resistivity of alloys which it is more than that of metals. Hence alloys we used to make for heating coils because it does not get oxidized at a high temperature. Then for insulator its resistivity is very high. Okay, with this all we can conclude today's class.